Welcome to Daily Papers, the podcast where we break down the latest research into bite-sized conversations.
Today, we're talking about something we've all experienced with AI chatbots. You ask it a question, and it gives you an answer that sounds incredibly confident, articulate, and completely wrong.
Right, it's called hallucination, and it's when an AI just makes stuff up. It's a huge problem, especially if we want to use these tools for important things like medical diagnoses or financial advice. A confident, wrong answer is way more dangerous than no answer at all.
Exactly. And this new paper from researchers at ByteDance and Carnegie Mellon asks a really interesting question. Why do they do this? And can we teach them to just say, I don't know?
I would love that. So what's the diagnosis? Why are AIs so confidently incorrect?
Well, the paper argues that we've accidentally trained them to be good test takers instead of honest communicators.
What's the difference?
Think back to a multiple choice test in school. If there's no penalty for guessing, the best strategy is to fill in an answer for every single question. Even if you have no idea, you might get lucky.
Okay, you maximize your potential score by never leaving anything blank.
Precisely, and that's how we've been training most large language models, or LLMs. We reward them for getting the answer right and penalize them for getting it wrong, but we don't really have a good way to reward them for admitting uncertainty. So just like that student, the AI learns that its best bet is always to take a shot, to guess.
And those guesses are the hallucinations we see. So the problem isn't just a random bug, it's a direct result of the training strategy. So how do we fix it? How do we turn the AI from a compulsive guesser into an honest communicator?
That's the core idea of the paper. They call it behavioral calibration. The goal is to teach the model to make its confidence level match its actual accuracy. So if it says it's 90% sure, it should be right about 90% of the time.
That sounds like a weather forecast. I don't just want the app to say rain or no rain. I want it to say there's a 30% chance of rain. That probability is what makes it useful.
That's a perfect analogy, and they achieve this using a method called reinforcement learning, which is basically training through trial and error. The AI tries to answer a question, and a virtual coach gives it a reward based on its performance.
But they must have changed the reward system, right? Otherwise, we're back to the guessing game.
They did. They created a much more sophisticated reward system. One of their most successful methods was called verbalized confidence. They trained the model to not only give an answer, but also to state a confidence score, like, I have 85% confident in this answer.
Okay, so the AI has to put a number on it.
Yes, and then the rewards are based on how well calibrated that number is. If the model says it's 95% confident and gets it right, great. But if it says it's 95% confident and gets it wrong, it gets a huge penalty. On the other hand, if it says it's only 10% confident and decides to abstain by saying, I don't know, that's perfectly fine. It gets a neutral score.
So you're not just rewarding correctness, you're rewarding accurate self-assessment. You're teaching the AI to be a good odds maker for its own answers.
That's exactly it. And the results are pretty stunning. They took a relatively small model with about 4 billion parameters. For context, some of the biggest models have over 1 trillion, and they trained it on difficult math problems using this new method.
And how did it do? Did it become a math genius?
Not necessarily. Its raw accuracy didn't skyrocket. But what it got incredibly good at was knowing when it was about to be wrong. They measured something they call the accuracy to hallucination ratio. Basically, for every hallucination it made, how many correct answers did it give?
And?
Their little 4 billion parameter model absolutely crushed some of the biggest frontier models out there, including models like GPT-5. The giant models were more accurate overall, but the smaller, calibrated model was far more honest about its own limits. It learned when to keep its mouth shut.
So it wasn't a better student, but it was a much more self-aware one. That's already incredible.
But here's the part that really blew me away. They took this model, which had only been trained on math, and they started asking it general knowledge questions, factual trivia.
It must have failed miserably. It wasn't trained on that.
Its accuracy was, as you'd expect, terrible. But here's the thing. It knew it was going to be terrible. It correctly identified the questions it didn't know the answer to and chose to abstain. The skill of being calibrated, of knowing what it knows, actually transferred to a completely different subject.
Wow, so calibration isn't just about knowing a specific topic, it's a separate, learnable meta skill for an AI.
That's what the paper proves. Factual accuracy and self-awareness can be decoupled. You can teach a model to be honest even if it doesn't know a lot of things.
The implications of that seem huge. You could have smaller, cheaper, but much more trustworthy AI models for specific critical tasks. A model that helps a doctor doesn't need to know everything, but it absolutely needs to know when it's out of its depth.
Absolutely. This research suggests that instead of just building bigger and bigger models in a race for raw accuracy, we can also focus on building more reliable and honest ones. It's a huge step towards an AI that we can actually trust.
So, in the future, when an AI gives you an answer, it might also give you a reliable hint about how much salt you should take it with. That's a future I'm ready for.
Me too.
That's all for today's Daily Papers. Join us next time for another look at the world of research.